On number 3, it is not possible because you can't be irregular and equilateral at the same time. So regular means all sides congruent, all angles congruent. Irregular means that all sides are not congruent. So you can't be equilateral, which means all sides congruent, and irregular at the same time. You can't. So that's why that one's not possible. Number 4 is also not possible. If I try to draw myself a trapezoid, well, sure, I could make that concave, but then it's not a trapezoid anymore, right? That's a pentagon. So as soon as I caved in one of the sides, I no longer had 4 sides. I had to add an extra side there. I had to have a pentagon, 5 sides. So that's why this one is also not possible. You cannot have a concave trapezoid. They're all convex, all of them. Number 19. The sum of the measures of 7 angles of an octagon is 1,000. Find the measure of the 8th angle. So I see some key words here. I see sum, and then we're doing the angles of an octagon. So let's grab that formula. You do not have to memorize your formulas. So sum and octagon. So I know I'm going to do n minus 2 times 180. And I'm pretty sure you get that there are 1,080 degrees in an octagon. Now, we've already used up 1,000 degrees. 7 out of the 8 angles add up to 1,000. So if we have 1,080 and we've used up 1,000, then the 8th angle must be an 80-degree angle. Number 20. How many sides, so that's n, how many sides does a regular polygon have if each exterior angle is 15? So I see the word exterior. That narrows it down to 2 formulas, well, a constant and a formula. Then I see the word each. So that means 1 exterior. So I want my formula for 1 exterior. And I know that it has a measure of 15. So all I have to do is solve that. I can put 15 over 1. I can cross multiply and divide. So it's really saying 360 times 1 divided by 15. So it's really saying 360 divided by 15. So n is 24. Sorry, that was weird. Okay. Doing more than I need to. 21, here we go. How many sides does a regular polygon have if each interior angle has a measure of 108? This is the one yesterday that I taught you a trick for. Remember? I said that this is kind of miserable. Kind of miserable. That's my unhappy face right there. Okay, so instead we know that every interior angle is a linear pair with its adjacent exterior angle. So I know that this is 72. I would much rather solve this one than that one. So we convert it from interior to exterior, then we do 360 divided by 72, and we realize it was a pentagon all along. 5 sides. Okay. 22. Find the number of sides of a polygon if the sum of its interior angles is twice the sum of its exterior angles. There's a lot of words here, and there's like no numbers in this problem. Yet we need to come up with the numbers, right? So, find the number of sides. Okay, so we are looking for n. Cool. The sum of the interior angles, well, let me just write that formula down. The sum of the interior angles is, what's the mathematical symbol for is? Translate is to math. Good. Is twice the sum of the exterior angles. What's the sum of the exterior angles? All the time, every time, no matter what, it's dun, 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 360. You guys can solve that. You can do it, okay? So we'll just do one way of solving it, which you don't really have to do it this way. But we have n minus 2 times 180 equals, I'll just go ahead and simplify that over there. And then it's a 2-step problem. Divide by 180 and add 2. See what I did there? The opposite of multiplying by 180 is dividing by 180. The opposite of minus 2 is plus 2, and equals 6. 23, this one is a lot like 22, so I'm going to work it much quicker than I did 22 because I've already explained it. Sum of the interior angles is 4 times the sum of the exterior angles. I'm only setting number 23 up. I'm not going to solve it. You would just clean it up, divide by 180, and add 2. Number 25. We know that we have a quadrilateral. You probably already memorized this one. The angles of a quadrilateral add up to 360. This is a lot like the warm-up. They are in the ratio of 1 to 2 to 3 to 4. So we're going to do what we did on the warm-up. 1x, 2x, 3x, 4x. Do that every time you see the word ratio. Attach an x to it and add them up. Okay? So how many do we have? Let's see. 4, 5, 6, 7, 8, 9, 10. 10x equals 360. Just like in the warm-up, x ends up being 36. So let's draw a quadrilateral. Let's name it A, B, C, D. And let's find out what the angles are. Angle A is 1x. It's 36. Angle B is 2x. 2 times 36. Angle C is 3 times 36. And angle D is 4 times 36. So I have a quadrilateral with those angles. Now, my favorite part of the problem, determine which segments are parallel. Well, now we have to use stuff from last unit and really stuff from the last semester. Our 36 and 72 are those supplementary? Because if same side interior angles are supplementary, then we have parallel lines. But if they're not supplementary, then we don't. 36 and 72 are not supplementary. So AD is not parallel to BC. Not. What about this? 36 and 144. Those are supplementary. So AB is parallel to CD and not the other way around. AD is not parallel to BC. So honestly, what shape is this? We know the name of it. What shape is this? It's a trapezoid. It has one pair of opposite sides parallel. Exactly one pair. That's the definition of a trapezoid. So number 25 was a trapezoid. 27, here we go. Now, what I always do first when I'm looking at these problems is I count the number of sides and I find out how many degrees are in the shape. Because we always want to have that as our grounding. How many degrees are in here? How many degrees do we have to work with? So on number 27, that is a 6-sided shape. It's a hexagon. 6 minus 2 times 180. Look at that. We have 720 degrees to work with. Okay. Then the next thing I do is I look for symmetry. Let me tell you what I'm talking about. This pink diagonal, does bisect the angle. This purple diagonal does not bisect the angle. How do I know? Because Ms. Tanton taught you never assume, oh, it looks like it bisects, so I'm going to say it does. No, never assume. What I use to do this, and it might be useful for you to get a highlighter out sometimes, I ask myself if that is a line of symmetry. Because if it's a line of symmetry, it does bisect the angle. Take a look at that pink line. On the right, I've got, and remember, these are all regular, very important. On the right, I've got 3 sides. On the left, I've got 3 sides. That is a line of symmetry. That splits my shape perfectly in half. So, if I can find the measure of each angle, 720 divided by 6, they're all 120. So I know for E, at least for E, it's 120 bisected. It's 120 divided by 2, and that's where the 60 comes from. Now, I can't do that for F, so I have to be careful. F is not 60. It's not 120 divided by 2. For F, what I'm going to do is I'm going to use triangles to my advantage. And they're not just regular triangles. They are isosceles triangles. The reason I know this is isosceles is that if this is a regular polygon, a regular hexagon, then all sides are congruent. So that teal triangle I just drew is isosceles. And I can find the measure of every angle of this hexagon. So this angle is 120. So I have an isosceles triangle with a vertex angle of 120. Oh, looky there. Now I can find my base angles. So 180 minus 120 divided by 2, and that's why the answer to F is 30. So that's a problem you need to know how to solve. Now 29 and 30 are a little bit more challenging than that one, and you won't see this one as often, but let's do it anyways. What did Miss Tanton say to do first? Take your inventory. How many sides do you have? So 25 is a nonagon, right? So 9 minus 2 times 180, we have 1,260 degrees to work with. Let's go ahead and take that number and let's divide by 9. When I divide by 9, I know the measure of every interior angle. 140, 140, well, this whole angle is 140, the whole thing. Every angle of this nonagon, because it's regular, is 140. I'm going to work with K first. Remember what I was saying, you're kind of looking for a lot of symmetry. Now, this has an odd number of sides. So K, that segment that makes K, does not bisect the angle. Those other segments, they don't bisect any angles at all. Darn, can't use that. What I am going to use to solve for K is I'm going to use this shape right here. I'm going to even pull it out. I know you can't do that on your homework, but I'm going to show you what I'm doing here. You see that shape that I just pulled out? That shape, let's see, is a 1, 2, 3, 4, 5. That's a pentagon, right? I know 3 out of the 5 angles. Do you agree with me that the remaining 2 angles, K and this other one, do you agree with me that they're definitely congruent, right? Because this shape is symmetrical, it's a regular polygon, and so they are going to be the same measure. Is that okay with everyone? That's the key to this one. So I'm going to take 140. I'm going to multiply it by 3. Now, how many degrees are in a pentagon? You might memorize this one because this one does come up a lot. There's 540 degrees in a pentagon. So I'm going to subtract what I got so far. 140 times 3 is 420. So 540 minus 420. I've got 120 degrees, and now I divide it by 2. 60. I told you, when in doubt, guess 60, right? So we've now found K. There might have been an easier way to do that. If you find an easier way, you let me know. Okay. The way that I looked at L is I grabbed another shape from my figure. I grabbed this shape right here to start with. I know in this shape that this is 140 because remember, every angle of this nonagon is 140. So I know those are 140, and I kind of did the same thing I did earlier. That's a trapezoid, right? That has 2 remaining angles. It's an isosceles trapezoid, in fact. And so I can find those 2 angles. So I can do 360 minus 140, and divide by 2. Or I could have just found the supplement of 140. 40, 40. So if I put that on a picture, that's 40 and 40. Then, remember from our earlier problem, we found that this was 60. We know that this whole angle is 140. 140 minus 60 is 80. So in this little triangle right here, I've got 80, 40, and a missing angle. So if I subtract 80 and 40 from 180, I get 60, and 60 is a vertical angle with L. So 60, 60. Okay, number 30. Now this one's a little bit different because the whole shape is not a convex shape, right? So I like to view this not as a star, but I like to view it as a pentagon surrounded by isosceles triangles. A pentagon surrounded by isosceles triangles. So let's first take a look at that pentagon, and you can calculate how many degrees are in it, or maybe you've already memorized that there are 540 degrees in a pentagon. So each angle of our pentagon, each angle, 540 divided by 5, is 108. So what I did is I looked at this trapezoid. So this is 108 and 108. I looked at this trapezoid right here. 108, 108. This is S, and this would be S as well, because these are going to be congruent, because it's isosceles trapezoid. So to find S, I'm using that trapezoid. I'm really just finding the supplement of 108. And we're getting 72. You can also just subtract it from 360 and divide by 2 if you want to think of it that way. Okay? So now we know S. Let's focus on Q. Let's work with Q for a while. Now, to find Q, oh, that's an easy one. It's just a vertical angle with one of our angles in our pentagon. This angle is 108. And you see how Q is a vertical angle with that? Phew! We got an easy one, guys. All right, so awesome. Q is 108 because it's vertical angles. How did I get 108? I took the number of degrees in a pentagon, just a reminder, and I divided by 5 because there's 5 angles in a pentagon. Okay, now we need to find R, and we're done. I would approach R as being an isosceles triangle. You can't assume that it's equilateral, but you can assume that it is isosceles. So we know that all of these angles, that's 108, 108. So if I did the linear pair of 108, this is 72 and 72. Are we okay with that? So we have an isosceles triangle with 72 and 72. 72 is an exterior angle of a pentagon. It's one exterior angle. So now we can just add them up. Yep, they're base angles. Add them up and subtract from 180, and that's how we get 36 degrees.